In notes number 6, we're going to talk about scale factor and how that affects our surface area of our 3D figures. So in number 1, we need to find the scale factor of a cylinder if the surface area of the first cylinder is 49 and the surface area of our second cylinder is 100. Now remember, scale factor is talking about the side ratio, not the surface area ratio. If we start with a surface area ratio of 49 over 100, and we need to find the scale factor, we have to go backwards. Remember, ratio is squared, so this is feet squared. The scale factor then would be comparing feet. So we need to take the square roots of each of those numbers to go backwards to find our scale factor. So the square root of 49 is 7, square root of 100 is 10. So our scale factor of the sides, this ratio of the sides would be 7 over 10. And number 2, when we have the scale factor, is 2 over 5. And we need to use it to find the ratio between the surface areas and the ratio between the volumes. You have to treat it 2 different ways. So if we need to take our scale factor and change it into surface area, we need to take each of those numbers and square them. If we need to take our scale factor and find the ratio volume ratio, then we need to take each of those numbers and raise it to the 3rd power. So for the scale factor of the surface area, we would take 2 squared and our 5 squared, so that would give us a 4 and a 25. If we're doing our volume, we would take 2 to the 3rd power and 5 to the 3rd power, so that would give us an 8 and a 125 for the volume ratio. So make sure you label your answers and kind of set up like columns like this. You can see the smallest version of your scale factor, so the side ratio versus the surface area ratio and your volume ratio. So keep your paper organized. Now if we need to move backwards, so number 3, we are given the volume ratio and we need to find the surface area ratio. So let's set up our paper with 3 separate columns again. And you might be wondering, why do we need the scale factor ratio? Or over here, this column is because the only way to get surface area is if you have the scale factor. So we need to use our volume ratio, work backwards to the scale factor, and then use the scale factor to go forwards for the surface area ratio. All right, so for the volume ratio, first check to see if you can reduce it, and we can. So the volume ratio is really 8 over 27. So now remember to go backwards with the volume ratio. We did this before in our volume unit. To find our scale factor, we need to take the cubed root of all of those numbers. So the cubed root of 8 is a 2. The cubed root of 27 is 3. So that means our scale factor of our sides, the side ratio, is 2 to 3. Now when we want to go forward to the scale factor, or our surface area ratio, sorry about that, we need to square each of our numbers for the scale factor. So 2 squared and 3 squared, so that gives us a 4 and a 9. So our surface area ratio then will be 4 over 9. Going on to number 4, 5, and 6, this is where we are going to take some of the dimensions or all of the dimensions and multiply it by something and see what the effect is on the surface area. So we did this with volume before, and we're going to do it again now with surface area. So in number 4, in a cone, we are going to change the radius and the height, and it's going to be multiplied by 3. So what I want you to do is we're going to make up our own problem. We're going to change the dimensions, and then we're going to compare those areas to each other. So I set up my paper with the old cone and the new cone. My old cone, I'm going to make my radius 3. I'm going to do my height as 4, and then my slant height here is going to be a 5. So if you notice, that's a right triangle, and that's a Pythagorean triple. So I just know that those numbers all do relate to each other correctly. Then next, if we need to adjust our surface area, we need to know how it's going to be changed. So the radius and the height are multiplied by 3. That means my radius is now going to be a 9. My height then will be, instead of 4, it's going to be a 12. And if we did Pythagorean theorem again, that our slant height then will be a 15. So it's also changed as well. To find our surface area now, let's go ahead and find our surface area of the old cone. So we've got pi r times the slant height, so L, 5, plus pi r squared, so pi 3 squared. So this gives me 15 pi plus 9 pi. I add those together and I get a 24 pi. So let's leave that the way it is, and now let's find the surface area of the new cone. And on this one, I want you now to find the surface area of your new cone. The radius was 9, the slant height is 15, and then our radius is 9 again. So 9 times 15 gives you 135 pi plus your 81 pi. So you should have gotten 216 pi. Now, when you want to find the ratio between them, we always have to take new divided by old. When we set ours up then, we get 216 pi over the old of 24 pi. Now, the pi's are going to cancel. So if you divide 216 by 24, you get 9. So it's 9 times larger than the original surface area. So this is something that I want you to write on your paper now. So when all the dimensions are changed, so here in our cone, all of our dimensions were changed, so our radius and our height, that we can take the scale factor numbers, that was our 3 up here, and we can square it because we're doing surface area. That will give us the number of times it will change by. So if we take our 3, we square it, we get the 9, and then here's our example to show that is why it does equal the 9. So always remember this, so if all the dimensions are changed, there is a rule that you can take and then you can follow to find how the surface area is changed. In number 5, if we just change one of the dimensions, that we cannot follow that same rule. So you'd have to actually go through and make your new question, compare it, and then that'll tell you the way that your surface area is going to be affected. So you can skip this one if you want to, otherwise I'm going to show you how to set that one up. Here's my example, because I'm going to go through this one pretty quick since you don't really have to do this one. Your radius then is going to be divided by 4 because it is times 1/4. So my new radius would be a 2, but notice my other two numbers are not changing at all. And also if you notice on this one in your directions in your paper, it says a different shape right here, but switch that to a right cone so it matches my example on here because I did switch that. So then if we want to find the new surface area and the old surface area and compare them, this is how it's going to be set up. And when we figure both of those out, we get the old surface area was 144, the new is 24 pi, and both those have pi. Remember, if we compare the new divided by the old, we get 24 pi divided by 144 pi. The pi's cancel, and in this case, it just reduces down to 1/6. So if our radius was changed by a factor of 1/4 and not the height or the slant height, then our new surface area is really 1/6 the size. So it really shows you that when you change one dimension in any of your figures, that you must work out the example to compare your surface areas. There's not going to be a specific rule, because if you notice 1/4 to 1/6, there's no really rhyme or reason of why it is 1/6. That's just the way that it works out. So going back to number 6, I want you to first notice that I changed one of the wording, change that to doubled on your paper, because yours says tripled, so change it to doubled. And we are now going to change all of the dimensions because it says that the dimensions of a square pyramid are doubled. So it doesn't tell us what they originally are, but we want all of them to change. So again, we're going to set up an example of one, and then we're going to change it and then see how it changes so we can make up that rule. All right, so I also wanted this to be a 3, 4, 5 triangle. So if I know that the distance right there needs to be 3, that means that the whole length of my side needs to be 6. And I want the height to be 4 and my slant height to be a 5. So I just want to make sure that it actually works. So my surface area for the old one, when we set this up for your pyramid, we have 1/2 capital P times L plus the capital B. So we have 1/2. My perimeter would be my 6 plus 6 plus 6 plus 6. So we get 24. The slant height we already have is 5. And then the area of my base would be 36, so 6 times 6. We get a 60 plus 36, and when I add those together, we get 96 for our old surface area. So now let's adjust our new pyramid and see if we can come up with our rule. Now all the dimensions are going to be doubled, so that means everything. So this is going to be a 6 right there. My height then, instead of the 4, is going to be an 8. My slant height will be a 10, and then each of the side lengths will be 12 and 12. Now go ahead, and I want you now to find out what is the new surface area going to equal. The perimeter, so 12 plus 12 plus 12 plus 12, or 12 times 4, gives you 48. You should have used then the slant height should be a 10. Your area of your base, so 12 times 12, gives you 144. When you combine that together, you get 240 plus your 144, so your total would be 384 for your surface area. Now remember, when we need to compare our new over the old, we take our 384 divided by our 96 and see how they change. So if we divide that, we get a 4, so it's 4 times as large. Now remember, when we change all dimensions, we could take the scale factor number and we can raise it to the second power, and that would give us how many times it changed. And if we do that, so we take 2 squared, we do get 4. So before you end, make sure that you write that statement out so you understand why it is 4 times larger. And it only works when all dimensions are changed. So you could avoid working out the whole problem if you remember what that rule is. But remember, if there's one change, so one dimension is changed, that you do need to work out both the example and your new problem to compare with the surface area and how the surface area will compare to each other.